make people to be aware about this YouTube channel that is assisting learners across South Africa. Once more, I welcome you to Chemical Equilibrium lesson. In this topic, we will deal with the whole content that have got something to do with chemical equilibrium. We'll exhaust the whole exam guideline for chemical equilibrium. We'll talk about factors that affect chemical equilibrium, all of them. We'll talk about factors that affect the equilibrium constant. So stay tuned. We're starting with chemical equilibrium. Ladies and gentlemen, you need to notice that when we talk about a chemical equilibrium, although I'm going to write a definition of chemical equilibrium, but before explain a lot of things, understand that the chemical equilibrium is a state where the rate of the forward reaction is equals to the rate of a reverse reaction. Before I say a lot of things, is that if I have a graph like this, and then here I have time, and here I have concentration, here I have concentration. If I have a line which is like that, then I have a line like that. Then if I have something like this, a place where there is a stable line, a line which is straight and stable, it represents chemical equilibrium. So this straight line represents a chemical equilibrium. Whenever you see a straight line in this topic, notice that the straight line represents chemical equilibrium. This line represents also chemical equilibrium. But where the line starts to shift, you find that it's either the line goes up or it goes down. That represents a disturbance where chemical equilibrium is disturbed. Ladies and gentlemen, we are starting. You need to understand that chemical equilibrium will never be achieved unless we have an isolated system. We've got two types of system where we perform our reactions. We have an open system and a closed system. Chemical equilibrium will only occur when the system is closed. Therefore, it is imperative that we start from an open system and a closed system. Then let us talk about it. What is an open system? What is an open system? What is an open system? An open system is a system that continuously interact with its environment. So an open system is a kind of a system where there is an exchange of energies between itself and the environment. So an open system cannot be able to reach equilibrium. Open system cannot be able to reach equilibrium. So you need to notice that whenever we have an open system whereby the content of the experiments that are able to escape the system, it means such system is open and it cannot be able to reach equilibrium. Equilibrium can only be reached when we have a closed system. A closed system, it is the only system whereby equilibrium is going to be reached. And a closed system does not interact interact with its environment, does not interact with an environment, and there's no exchange of energies. There's no exchange of energy with the environment. With the environment. So when we say that a system is closed, it means that the system does not exchange energies, does not interact with its environment. An example of a closed system, look what I'm having. I'm having this bottled. The bottle is closed. So since it's closed, the content that is here is isolated from this environment. There is nothing that can get in this bottle, and there is nothing that can escape. So we say that this system is what? Is closed. So that is the difference between a closed system and an open system. When we talk about an open system, it's a system whereby things from the environment, they can be able to get in the system and leave the system. Such system is open. It cannot be able to reach equilibrium. So the only system that is able to reach equilibrium is a closed system. And slowly but surely, we're moving toward you understanding chemical equilibrium. These are the first two conditions, or the condition for equilibrium to be reached. Chemical equilibrium can only be reached if we have a closed system. If the system is not closed, it means that the chemical equilibrium will not be reached. Ladies and gentlemen, you need to understand that this chemical equilibrium, it is going to be maintained in a specific type of a reaction. Chemical equilibrium can only exist in a specific type of a reaction. Remember, in the introduction, I've just indicated to you that chemical equilibrium first requires a closed system, right? The second thing, the chemical equilibrium, for it to be achieved, the reaction should be a reversible reaction, meaning that we need to understand what is a reversible reaction. A reversible reaction, what is a reversible reaction? A reversible reaction, and you need to know this definition because you are going to be asked in the exam. A reversible reaction is when products can be converted back to reactants. A reversible reaction is a type of a reaction where product can be converted back to reactants. It means that such a reaction is a reversible reaction. If a reaction is not a reversible reaction, chemical equilibrium cannot be achieved for such a reaction. Okay, so I have just given you two conditions for chemical reaction, for chemical equilibrium to be achieved. The system must be a closed system. The second one is that the reaction must be a reversible reaction. What is a reversible reaction? A reaction where product can be converted back to reactants. Ladies and gentlemen, for a reversible reaction, we use the two-arrow system. We use two-arrow system to represent a reversible reaction. You will see an arrow which is pointing forward and another arrow which is pointing backward. These two arrows, the one which is pointing forward and the other one which is pointing backward, these arrows, they represent a reversible reaction. It means that reactants can be converted to products and products can be converted to reactants. This is a reversible reaction. Sometimes in the reactions that we have come across from grade 10 and 11, you'll find we have only one arrow which is pointing forward. This arrow, it means that the reaction that we have is not a reversible reaction. And we are going to come a kind of a reaction which is not reversible. Even in the part where we are dealing with the rate of reaction, you will find that we have reactions that are not reversible. There's only one arrow. So you need to understand that two arrow means the reaction is reversible and one arrow means the reaction is irreversible. It cannot be reversed. Okay, we are continuing with the chemical equilibrium. We've just talked about a reversible reaction. Ladies and gentlemen, you saw that in reversible reaction and we have products being converted back to reactants. If we have A, we mix it with B, we may form C and D. This is a reaction. This reaction, it is not reversible. Why am I saying it is not reversible? There is only one arrow. But if we want to make it a reversible reaction, what do? We are going to draw two arrows. The arrow is going to point forward and the other one is going to point backward. This represents a reversible reaction. And the chemical that we start with, the chemicals that we start with, we call them reactants. We call them reactants. Then what we're going to form by mixing the reactants, it is called a product. It is called products. So the definition of a reversible reaction says that a reversible reaction is the reaction where products can be converted back to reactants. You understand? That is a reversible reaction. Those are the main two conditions for a chemical equilibrium to be reached. The first one, the system must be a closed system. The second one, the reaction must be reversible. Then what is a reversible reaction? A type of a reaction where products can be converted back to reactants. We are moving forward. Since now we have talked about the characteristics of reversible reaction and we've talked about the condition for us to achieve chemical equilibrium, then we can be able to talk about chemical equilibrium. What is this chemical equilibrium? What is this chemical equilibrium? I've just showed you that reversible reaction is a type of a reaction where product can be converted back to reactants and vice versa. We're just going to have a second where products are being converted to reactants and reactants are being converted to products. Products are being converted to reactants and reactants are converted to products. So, yeah. Then let us talk about this chemical equilibrium. What is chemical equilibrium? What is chemical equilibrium? What do we mean by this chemical equilibrium? I've just indicated to you two conditions for chemical equilibrium. But what do we mean by this chemical equilibrium? They say that chemical equilibrium is a dynamic equilibrium. It's a dynamic equilibrium where the rate of the forward reaction. It's a dynamic equilibrium where the rate of the forward reaction is equals to the rate of the reverse reaction. There are mistakes that you as our learners, you always make. You will find a learner writing chemical equilibrium is a reaction where the forward reaction is equals to the reverse reaction. It is incorrect, my learners. We need to say where the rate of the forward, we must not leave the word the rate. We must not just say forward reaction is equals to reverse reaction. It becomes incorrect. We need to say the rate of the forward reaction is equals to the rate of the reverse reaction. So take note, do not leave the word rate of and the rate of. So chemical equilibrium is a dynamic equilibrium where the rate of the forward reaction is equal to the rate of the reverse reaction. Someone will even, sometimes they will say, define dynamic equilibrium. Define dynamic equilibrium. I came across a situation where someone said, I understand the definition of chemical equilibrium, but I didn't know the one of dynamic equilibrium. So take note, dynamic equilibrium and equilibrium, it means the same thing. So it generally, chemical equilibrium is a state in a chemical reaction where the rate of the forward reaction is equal to the rate of the reverse reaction. I hope you now understood what is happening, because now I'm going to go into details in chemical equilibrium. I'm going to go into details in chemical equilibrium. Okay, let us move forward and we talk about the factors that affect the rate of reaction. The factors that affect the rate of reaction. Factors that affect the rate of reaction. Factors that affect not the rate of reaction, colleagues. Factors that affect chemical equilibrium, because we've already talked about factors that affect the rate of reaction in lesson number 1. Here we're focusing on chemical equilibrium. So now we're talking about the factors that affect the position, factors that affect the position of chemical equilibrium. So now I almost made a mistake, because now we are no longer in the topic of chemical rate of reaction. We are now in the topic of chemical equilibrium. So we're talking about the factors that affect the equilibrium position. Factors that affect the equilibrium position. Factors that affect the equilibrium position. And those factors, factor number 1 is temperature. It means temperature can affect equilibrium. Temperature can affect equilibrium. Then we can talk about concentration. Concentration can affect the what? The equilibrium. Then we talk about pressure. This pressure affect reactants and products that are in gas phase. Pressure is going to affect gases. Then concentration is going to affect things that are in aqueous, Then temperature is going to affect all. Temperature can affect the molecules of gases. It can affect the molecules of aqueous. And yes, so temperature can basically affect gases and everything. But pressure is specifically for gases. So these are the 3 factors that affect the equilibrium position. You need to understand that when they ask you questions in the exams, they will not request you to mention these factors. They will not ask you that what are the factors that affect equilibrium position, then you list them. It is not going to be like that. Meaning that in this lesson, we need to exhaust how temperature affect equilibrium position, how concentration affect equilibrium position, and how pressure affect equilibrium position. So now we need to explain how each of the factors affect equilibrium position. So now we need to talk about how these factors are going to affect equilibrium position. But before we talk about how this factor affect equilibrium position, there is a principle that we need to talk about, and this principle is going to make us understand how everything works. Ladies and gentlemen, that leads us to the Le Chatelier's principle. There is what we call Le Chatelier's principle. We need to understand this Le Chatelier's principle. Notice that this principle is examinable. They are going to ask you in the exam. Le Chatelier's principle. After talking about Le Chatelier's principle, we're going to talk about how this Le Chatelier's principle works with those factors that affect the equilibrium position. Because in the exams, they will say, explain how, using Le Chatelier's principle, how temperature is going to affect. Explain how temperature is going to affect the equilibrium position. Use Le Chatelier's principle. Then that's where Le Chatelier's principle comes in. But they can also ask you to state it in the exam. What does Le Chatelier's principle say? It says when the equilibrium are in a closed system. Remember that equilibrium can only be achieved on a closed system. Is disturbed. When equilibrium in a closed system is disturbed, then what's going to happen? The system will reinstate. The system will reinstate a new equilibrium. A new equilibrium. The system will reinstate a new equilibrium by favoring the reaction that will oppose the disturbance. What does Le Chatelier's principle say? It says when the equilibrium in a closed system is disturbed, the system will reinstate a new equilibrium by favoring a reaction that will oppose the disturbance. So we need to explain this in details. Ladies and gentlemen, you can see the word disturbance and disturbed. What does it mean? We just talked about factors that affect equilibrium position. So those factors that affect equilibrium position, namely temperature, concentration, and pressure. Those three factors, they are the disturbances that we're talking about. So when we say we're in a closed system, when equilibrium is disturbed, the system will reinstate a new equilibrium by opposing a reaction that opposes the disturbance. The disturbance that we're talking about is this temperature. It means temperature is a disturbance. Concentration is a disturbance. Pressure is a disturbance. So you need to take note how these factors that affect equilibrium position are related with this Le Chatelier's principle. We use Le Chatelier's principle to explain how each factor works, how each factor functions. I hope we are together. In this state, you need to start to pay more attention because I'm going to explain something that may be complicated for some of you. Okay, I want to explain something complicated, just a little bit, but I will uncomplicate it. Before I move further, let me explain what is happening with equilibrium. Let me make you understand what is happening with equilibrium. Ladies and gentlemen, let's take, we have a pot. You see, we have a pot with handles. Then we put water inside the pot. We put water inside the pot. Then we do what? We close the pot. You see, the pot now is closed. Then there is fire. This is firewood. There's fire. Then the temperature of the water is going to what? Is going to rise. As this temperature starts to rise, water will reach a point where it will start to boil. You will see our water boiling. But because this pot is closed, we have made this system to be a closed system. I'm just giving you an ideal example using a pot. So, there is nothing that is going to escape this pot. When water vapor is into this water is going to be converted to water vapor. The water vapor will try to escape, but it will not manage to escape. It will hit the lid of the pot. You see? It will hit the lid of the pot. When it hits the lid of the pot, it means the water that was inside here is going to decrease. Why is it decreasing? Because some of the amount of water have just escaped using a water vapor, but did not manage to completely leave the system. The water vapor was just trapped by the what? By the lid. Then what will happen to that water vapor? It will start to condense. Condense means to cool down. It will start to cool down. When it cool down, it means it will be converted to what? To water, H2O liquid. When it is converted to water, H2O liquid, it will drop again. It will drop inside this pot where there is liquid water. You understand? So what is going to happen here? As another amount of water get converted to water vapor, another amount of water will be dropping. When another amount of water get converted to water vapor and get trapped by the lid, another amount of water will be dropping down. So in that state whereby there is no increase of water and there is no decrease of water, it means this system have reached equilibrium. Do you understand? Equilibrium is a state in a chemical reaction where the reverse reaction, the rate of the reverse reaction is equals to the rate of the forward reaction. What's going to happen? The forward reaction is the conversion of water liquid to water vapor. Then the reverse reaction is the conversion of water vapor to liquid. You see that as the water vapor try to escape the pot, it gets trapped by the lid. Then it condenses. Then that water that have condensed, it is going to do what? It is going to drop back to the pot. But as it drops down, another water vapor, it is going to leave the pot. You understand? So as something is leaving, something is getting in. As something is leaving, something else is getting in. So what does that mean? It means that we're not going to have a decrease and we're not going to have an increase. Why? It's because what is leaving is equals to what is getting in. So we say that equilibrium is reached. That's what we mean by equilibrium. It means equilibrium is reached. Then now we talk about disturbance. Now we talk about disturbance. I've indicated to you that disturbance is what? Disturbance is temperature, concentration, pressure. All those three things, they are disturbance. Look at it. Water is starting to do what? To boil. As water is boiling in a closed system, water vapor try to escape, but it gets trapped by a lid, condensed, fall back to the pan. The same process repeats itself, and we say it has reached equilibrium. Then, if we want to disturb this system, what can we do? We can switch off the fire. Can switch off the fire. When we switch off the fire, we have, what did we do? We have decreased the temperature. So since we have decreased the temperature, it means equilibrium is going to be affected because the water will stop boiling, and that conversion of water to water vapor and condensation is going to do what? It is no longer going to be there. It means we have disturbed equilibrium. Our system is no longer at equilibrium because we switched off the fire. We have disturbed the equilibrium by doing what? Decreasing temperature. Oh, what can we do? If the water is boiling and there is evaporation and condensation at the same time, then equilibrium is reached. We can take another amount of water, which is not boiling, which is outside. We open this system and we pour the water inside this system. We have disturbed the system because water will immediately start boiling because we just increase the what? The concentration. You understand? So when we talk about disturbing the system, that's what we mean. Is either we increase the temperature or we lower down the temperature or we increase the concentration. When we do any of those three factors that affect the equilibrium position, it will mean that we have disturbed equilibrium. I hope by this analogy you understand when we talk about disturbing equilibrium. Okay, I'm going to start from temperature. I'm going to start from temperature. Before I say a lot of things, I want you to understand this. Let us talk about increase in temperature. Okay. Before we talk about increase in temperature, let us talk about endothermic reaction, thermic reaction, and exothermic reaction. Endothermic reaction and exothermic reaction. What is an endothermic reaction? An endothermic reaction is the one that absorbs energy, then energy is absorbed. Then exothermic reaction is the one that releases energy. And it is very important, especially when we are performing a reaction. You find that we are doing an experiment. Experiment 1, experiment 2, experiment 3. Then the temperature during experiment. You see, this is the temperature when we are performing the experiment. Then temperature after. Look what we have for experiment 1, experiment 2, experiment 3. The temperature during experiment, we perform this experiment at the same temperature, 20 degrees. All the three experiments, we perform them at 20 degrees. But after the reaction, we find here we have 37 degrees, here we have 42 degrees, here we have 50 degrees. Let us check what happened. Do we have are this reaction endothermic or exothermic? It is very important. This reaction are exothermic. I know someone will say, but there is an increase in temperature. Look, an exothermic reaction is the one that releases energy. So, it means that We started with 20 degrees when we were performing our experiment. Then energy was not absorbed by the system, because if energy was absorbed by the system was going to take in the energy to itself. But instead, the system did what? Released the energy to the environment, meaning that the energy that we're going to have in the environment is going to be much, because the energy was released. That's why an increase in temperature represents an exothermic reaction, because the heat energy was released in the system. We can even say that endothermic reaction, heat. Then heat is a reactant. Yes, it's a reactant. It means if we have A plus B, we must also add what? Heat, and we produce what? C plus D. You see? But an exothermic reaction, heat is a product. Exothermic reaction, heat is a product. For exothermic reaction, heat is a product. It is going to give off heat. That's why if we were to represent an exothermic reaction, we are going to have what? We are going to have A plus B. Then we produce C plus D plus what? Plus heat. That's why you see an increase in temperature. Whenever we start our reaction and we perform it at this particular temperature, then we suddenly have an increase in temperature. It means the energy was given off. It means the energy was given off. Energy was released. That's why energy is one of our products. That's why there's an increase in temperature. It means that these three experiments, these three reactions, they are exothermic. I hope you understood what is happening. I hope you understood what is happening. So, endothermic reaction take in heat. Endothermic reaction is going to take in heat, is going to take in energy. Heat is a reactant, but endothermic heat is given off, meaning that heat is a product. Okay. Why am I taking you to endothermic reaction? I told you that I want us to talk about how does temperature disturb a reaction? How does temperature disturb the equilibrium position? Let us talk about this. An increase in temperature favor endothermic reaction. An increase in temperature is going to favor endothermic reaction. What do we mean by an increase in temperature favor endothermic reaction? Remember, an endothermic reaction is a type of a reaction that is going to take in what? Heat. Heat is needed because heat is a reactant on endothermic reaction. Meaning that if we increase the temperature, we are supplying endothermic reaction with heat that it needs, because it use heat as its reactant to produce the product. That's why an increase in temperature favors the endothermic reaction, as I wrote here. Then decrease in temperature favor the exothermic reaction. So when we decrease the temperature, remember that an exothermic reaction, it is giving heat off. Heat is released to the environment for exothermic reaction. It just releases heat to cool itself. It removes heat from its molecule. It just releases heat. So decrease in temperature favors the exothermic reaction. Let me give you an example of another exothermic reaction that is occurring in our body. You know, when we are working hard, we will sweat. When we sweat, according to life sciences, when we sweat, we are releasing our sweat, which is water. That is water. The sweat that is moving out through the perspiration, it is going to leave our body to be cooler. Sweating cools the body. Remember myself, I'm a teacher that have got maths, physics, and life sciences, and I'm actually doing my master's in life sciences. So when I teach physics, I've got a very strong background of life sciences. So I can use life sciences to explain this. I'm saying a decrease in temperature favors exothermic reaction. As I'm telling you that when you sweat, you are releasing heat. When you sweat, you are releasing heat. That's why after sweating, you find that you have cooled off. You no longer feel very warm and hot as you were feeling. So sweating cools your body off. So that process of sweating is an exothermic reaction because it releases heat. That's why a decrease in temperature favors exothermic reaction. Because when you sweat, you are trying to do what? You are trying to decrease your body temperature by sweating. So decrease in temperature favors exothermic reaction. Increase in temperature favors endothermic reaction. So now, these two statements are very important. We are going to use the Chatelier's principle to explain how temperature affect the equilibrium position. We use these two. I hope you have understood what I'm trying to explain. Increase in temperature favor endothermic reaction. Decrease in temperature favor the exothermic reaction. These are the two statements that you need to take in mind as we are going to explain how temperature can affect and change the equilibrium position. Okay, now let's say I say the enthalpy is greater than zero. When enthalpy is greater than zero, you know from grade 11 work that it means that this reaction is endothermic. The reaction is endothermic. Then when enthalpy delta H is less than zero, it means that the reaction is exothermic. These are one of the things that we need to remember. These are one of the things that we need to take note, that delta H greater than zero, it means the reaction is endothermic. Delta H less than zero, it means the reaction is exothermic. Then we need to explain what is happening. Let's say I give you a reaction and I say the reaction is endothermic, and I say I have A plus B where I form, it's a reversible reaction, where I form C and D. Right? This means that this reaction is endothermic. It's very important for you to understand this. Okay, when we say a reaction, when we say a reaction is exothermic, is endothermic or exothermic, isn't it? This one is endothermic. When we say a reaction is endothermic, we are referring to forward reaction. Whenever we're talking about this reaction, we say this reaction. Ladies and gentlemen, we're referring to the forward reaction. Remember that we always deal with reaction A plus B forming C plus D. You see this one, which is not reversible. So when we say reaction, we're talking about reaction means from reactant to product. That's what the reaction means. When we use the word reaction, we're talking about reactants to product. So when we say this whole reaction is endothermic, we are referring to the what? To the forward reaction. It's a matter of a language. The statement that I've just said, it is very important. When I say reaction is endothermic, it means I mean that forward reaction is endothermic. We are just taking it back like this. Reaction means the forward reaction, as we have always dealt with questions like this where we have one arrow. So when we say the reaction is endothermic, what referring to the forward reaction. Can you see that? Okay, it's a language. Next time when you come across a question like this, you see delta H is greater than 0. It means that the reaction is what? Is endothermic. The forward reaction is endothermic. Which one is the forward reaction here? Forward reaction is the formation of product. Forward reaction. Forward reaction for this one. Forward reaction is the formation of C plus D, the product. That is the forward reaction. The forward reaction here is the formation of what? Of C and D. What about a reverse reaction here? The reverse reaction here is the what? Is formation of A plus B. Those are what? Reactants. So the reverse reaction is remember definition of reverse reaction is that is a reaction whereby products are converted back to reactants. So the reverse reaction is the formation of A and B. Reverse reaction is responsible for forming what? The reactants. Is responsible for forming the what? The reactants. Okay. Now we're still mastering the language. Colleagues, you can see I'm teaching powerful stuff here. If you haven't subscribed, please don't just watch. Subscribe to this channel. Subscribing does not cost you a thing. Just subscribe so that we can be able to continue to assist you. Danko. Okay. I've just indicated to you that if you see delta H is greater than 0, it means the forward reaction is endothermic reaction. Okay, let me give you an important statement here. Let me give you an important statement. It's the matter of a language. So if a forward reaction is endothermic, then the reverse reaction is exothermic. If the forward reaction is endothermic, the reverse reaction is exothermic, and vice versa. It is very important for us to understand. If a forward reaction is endothermic, reverse reaction is exothermic. If a forward reaction is exothermic, it means reverse reaction is endothermic. You need to understand that a forward reaction can be exothermic. You need to understand that a forward reaction can be exothermic, and the reverse reaction can be exothermic. A reverse reaction can also be endothermic. But you need to note that if the forward reaction is exothermic, then the reverse reaction is endothermic. You need to understand. But there is one statement that I've just told you. I told you that an increase in temperature favors endothermic reaction. A decrease in temperature favors exothermic reaction. So the reaction that will be favored, it will depend which one is endothermic. As I'm indicating to you that if a forward reaction is endothermic, reverse reaction is exothermic, or if a forward reaction is exothermic, then the reverse reaction is endothermic. And then an increase in temperature will always favor a reverse reaction. Okay. So now, let us talk about how does temperature affect the position of equilibrium. How does temperature affect the position of equilibrium? Let us talk about it. How does temperature affect the position of equilibrium? Temperature. Look what is going to happen here. Right? Okay. Let's check. I give this to you. I say delta H is greater than 0. It means that the reaction is what? Is endothermic. Look, I have A plus B, and then I form C plus D. What does this mean? It means the forward reaction is what? Is endothermic. I told you that this talks about the forward reaction. It means the forward reaction is what? Is endothermic. So we know which one is forward reaction. The forward reaction is the formation of the product. Forward reaction is the formation of C and D. That is the forward reaction. Forward reaction is the formation of C and D. Then reverse reaction is the formation of what? Of A and B. Can you see? The reaction is endothermic, meaning the formation of C and D is what? Is endothermic because of this delta H greater than 0, which is talking about the forward reaction. Okay, so now let's check. I've given you this reaction. Can you see? You are seeing what is happening. And then I say that temperature, look what is happening. Look what is happening. Let me even make a graph for that. Let's take, I have a graph. That is the graph. This is the time. This is the concentration. This is, let's take, I talk about amount. Yeah. Amount. Moles. Let me talk about moles or molecules. Molecules. This is the time. This is the molecules. Can you see that? Then I will have this line. I will have this line. Can you see? I have the line. Then I can even draw the dots. I can even draw the dots. What does these two lines? Let me say solid line means forward reaction. Then dotted line means reverse reaction. You see? Solid line is the forward reaction, then dotted line is the what? Reverse reaction. Can you see that the rate of the forward reaction and the reverse reaction are equal here? They are equal because there is a straight line. When both of them are straight, it means we are at equilibrium. The rate of the forward reaction is equal to the rate of the reverse reaction, like what I was explaining to you about a pot and the lid. So we have equilibrium. Equilibrium is represented by a straight line. So now, look what is happening. Look. Then we suddenly have this. We suddenly have an increase. What is increasing? Forward reaction is increasing. Isn't it? I said the solid line. The solid line represents the forward reaction. I said the solid line represents the what? A forward reaction. So there is an increase. You can see that there is a what? There is an increase. Then look what happens. Look what happens. There is a decrease. Look, the reverse reaction is decreasing. I said the reverse reaction represents a what? Is represented by a dotted line. The number of moles of a reverse reaction, they are going down. What is happening? Forward reaction is C and D. Can you see? Forward reaction is C and D, meaning that C and D are increasing in the system. But A and B, they are doing what? They are decreasing according to this diagram. I want to explain how temperature affects the rate of reaction. Can you see that? So at this point here, everything was at equilibrium, meaning that the number of moles of A were equals to the number of moles of C and D. I mean in terms of formation. The formation of AB was equal to the formation of CD. The rate of the forward reaction was equal to the rate of a reverse reaction. Then what happened? Why do we have this one increasing and this one decreasing? It means at this point there was a disturbance. Equilibrium is disturbed. Equilibrium is what? is disturbed. Can you see? That's why we have an increase and we have a decrease. The one which is increasing, it means it's being favored. It is put to a more advantage. The one which is increasing, that's why it is increasing. It is being favored. That's what it means. To be favored, if you are favored, you are going to go up. You understand? So the one which is increasing, it is being what? Favored. The one which is decreasing, it is not being favored. You understand? Equilibrium was disturbed. So since this reaction is an endothermic reaction, right? And in this endothermic reaction, we have got what? We have got forward reaction forming C and D. And according to this, C and D are increasing. Why am I saying C and D are increasing? Because solid line represents a forward reaction. And the forward reaction form what? From the product, which is C and D. Reverse reaction from the reactants, which is A and B. But between A and B and C and D, which one is increasing? Is C and D, which is the product. Meaning that the formation of C and D is being favored. You understand? And the forward reaction is what? Is endothermic. So I can say, what made C and D to increase? What made C and D to increase? It means there was an increase in temperature. Now we are using Le Chatelier's principle. There was an increase in temperature. Why? Why is C and D increasing when there is an increase in temperature? Look, forward reaction is what? Is endothermic. Forward reaction is endothermic. How do I know? I just write delta H is greater than 0. And this, I told you that it is always referring to the forward reaction. If it can be less than 0, it will still be referring to the forward reaction. So it means forward reaction is what? Is endothermic. That's why temperature at this point is being increased. When the temperature is increased, it is going to favor the endothermic reaction, because I told you that an increase in temperature favors what? Endothermic reaction. So we're going to say increase in temperature favors the endothermic reaction. That's why you see the forward reaction being favored. The number of moles of forward reactions are going up. I hope you're understanding. The number of moles of forward reaction are going up here. So it means the forward reaction is being favored because the forward reaction is endothermic and temperature was increased. That's why we have this disturbance. So when temperature is increased, the endothermic reaction is going to be favored. And between these two, which one is endothermic reaction? Endothermic reaction is the formation of what? Of CD. You understand? So we are using Le Chatelier's principle. We are saying that a reaction that is going to oppose the disturbance is favored. It means at first, before we increase the temperature, we were having a high amount of A and B. So since we are having a high amount of B, what must happen? A and B must be decreased for this reaction to return to what? To equilibrium. That's why suddenly when we increase the temperature, we start to form to increase what? C and D, to decrease A and B so that the reaction can return to what? To equilibrium. That's what I can basically say that definition of the principle of Le Chatelier's principle, that the reaction that is going to oppose the disturbance will be favored. So the reaction which is opposing the disturbance is which one? Is the forward reaction which is being favored to decrease A and B so that C and D increase. And when C and D increase, we're going to form the what? The new equilibrium. So that's what it means. Increase in temperature favors the endothermic reaction. Then we're going to say forward reaction. Forward reaction is endothermic. I hope you can see. Forward reaction is endothermic. Why did we say forward reaction is endothermic? Because forward reaction is increasing. And as forward direction is increasing, what happened? Temperature was increased. There is a sudden increase in the number of moles of forward reaction when we increase temperature. And we know from theory that increase in temperature favors endothermic reaction. So it means that forward reaction is endothermic reaction. So that's how we explain. So what's going to happen? What's going to happen? We're going to have this. We're going to have an establishment of what? Of new equilibrium. So that's how we can explain that graph. It's nice that I'm drawing a graph this side, I'm explaining in words. I'm drawing a graph and I'm doing what? I'm explaining in words. So that's how temperature affects. You understand? Okay. Okay. I hope you understand how temperature can shift chemical equilibrium and how we can use the Chatelier's principle. The Chatelier's principle needs us to indicate which reaction is favored, and maybe we can also indicate that equilibrium shift to left. Equilibrium will shift that side, it will favor that side. You can say that. Yes, can say that. I hope you understand. When they say use the Chatelier's principle, you need to indicate which reaction is being favored. Which reaction is being favored? Which reaction is being favored between the two, whether it's a forward reaction or a reverse reaction. Okay, thank you very much. Let us explain, maybe we have an exothermic reaction then. Let us have an exothermic reaction. Okay, let me use the same thing. Let's say we say delta H is less than 0. Then we have A plus B forming C plus D. What does it mean when we say delta H is less than 0? What does it mean? It means that forward reaction is what? Forward reaction is exothermic. This one means forward reaction is exothermic. Forward reaction is exothermic. I told you that when they indicate our enthalpy, this enthalpy talks about the forward reaction. So it means this forward reaction is what? Is exothermic. This one addresses the forward reaction. This representation addresses the forward reaction. So in this case, forward reaction is exothermic. So ladies and gentlemen, let's say we have this situation, delta H is less than 0. Let us explain what's going to happen. Remember that if forward reaction is exothermic, it means reverse reaction is what? Is endothermic. Okay, let's say, let me just use the representation again. Let's say we have that representation. Our reaction is at equilibrium. How do we know that our reaction is at equilibrium? We have a what? A straight line. That straight line represents what? Equilibrium. We have a straight line. Two straight lines, they represent equilibrium. I hope you are still fine. So what's going to happen? What's going to happen? Let's say we have this. Let's say we suddenly have this. Let's say we suddenly have I will do the same key. Straight line, forward reaction. Solid line, forward. Dotted line, reverse. Can you see? Then we suddenly have this. Then we suddenly have, you see what we have? The solid line have decreased. You see that the solid line have decreased? The solid line, oh, let me write time. Let me write moles. Someone once complained that, a teacher once complained that I write graphs without writing units. Although it's a demonstration, but let us do it. Okay. So, look, the forward reaction is decreasing. In this case, forward reaction is decreasing, right? Reverse reaction is increasing. When reverse reaction increases, what does it mean? It means the reverse reaction is being favored. That's why it is what? It is increasing. So what can favor a reverse reaction here? Remember, a forward reaction is what? Is exothermic. A forward reaction is exothermic. In this case, and it is not favored. You can see that the forward direction, solid line, is decreasing, right? And remember that what favors exothermic reaction is a decrease in temperature from theory. So in this case, we are favoring a reverse reaction. So since we are favoring a reverse reaction, what is it that can favor a reverse reaction? It's increase in temperature. Increase in temperature. Increase in temperature. Why am I saying increase in temperature? It means that the reaction was at equilibrium at this point. It was at equilibrium at this point. Then there is a sudden increase in temperature. When we increase the temperature, it will favor the what? The reverse reaction. The reverse reaction, which is endothermic. Notice that you do not cram. You can see if you do not follow what I was explaining at first, now you may be confused. Look, this time around, a reverse reaction is endothermic. So it's the same thing as what I explained at first. It's just that I changed the reaction. This time around, reverse reaction is the one which is endothermic. You understand? That's why it's being favored. It's being favored when we increase the what? The temperature. So here there was an increase in temperature. That's why reverse reaction is increasing. Which one is reverse reaction? Reverse reaction is the formation of A and B, formation of reactants. You understand? So it is the one which is being favored by increasing what? The temperature. Why? Because increase in temperature favors what? Favors endothermic reaction. Increase in temperature favors endothermic reaction, meaning that reverse reaction is endothermic. That's why it is increasing when we increase the temperature. That's why it is increasing the reverse reaction. It is being favored because increasing temperature favors endothermic. Why am I saying that? I've indicated that this reaction is exothermic. And when I say this reaction is exothermic, it means the forward reaction is exothermic. What does it mean to the reverse reaction? The reverse reaction is endothermic. I told you that if forward reaction is endothermic, reverse is exothermic. If forward is exothermic, reverse is endothermic. You understand? So when we increase the temperature, the reverse reaction is going to be favored because the reverse reaction, surely it is endothermic because the forward reaction is exothermic. I hope you have understood how temperature affect equilibrium. Then we establish a new equilibrium. So here there was a disturbance. So I hope you understand how temperature affects equilibrium. Now I want to go to concentration. Then I conclude it by pressure. Then I talk about KC. Stay tuned. Okay, ladies and gentlemen, now I want us to talk about concentration. How does concentration disturb equilibrium? How does concentration causes the shift of the equilibrium position? How does concentration causes the shift in equilibrium position? Okay, let us see. Ladies and gentlemen, we have reactants, the reactants that I love very much, A plus B, then we form C plus D. Can you see that? Let me explain to you. Forward direction, form C and D. Forward direction, form C and D. Then reverse direction form A and B. And I hope learners from Majeje High School, I hope you are watching. Thank you very much. I visited Majeje some other time because those learners, they follow me a lot on YouTube. So even if you want me to come to your school, just notify me on the comment section. I can pay you a visit and just come and teach you only for one day. It's my passion to interact with learners. Okay. want to talk about how concentration can cause a shift in equilibrium position. So we have a reaction A plus B, C forming C and D. I was saying the forward reaction forms C and D, and the reverse reaction form A and B. Okay, so let us see what can happen. Let's take we do what? Let's take we have our reaction is there. I'm representing it. I've got a straight line. Equilibrium. This reaction is at equilibrium. The rate of the reverse and the forward reaction are equal. This is time. This is time. This is concentration. Concentration. You see? How does concentration affect the equilibrium? Okay? Let's say we have reached the equilibrium. It means the rate of the forward reaction is equals to the rate of the reverse reaction. That's why you see a straight line. A straight line represents that a reaction has reached equilibrium. Then, what do? We add, look, we add A molecules in the system. We add A molecules. Let's take, I have a syringe. You know, a syringe is one of the equipment that we use to measure the rate of reaction. We use a syringe and a stopwatch. I hope you know. Stopwatch is always there. So they will ask you, what are the equipment that we use to measure the rate of reaction? Stopwatch and a syringe, in case you come across that. A syringe, a burette, yes. So let's say I just add more molecule of A. Do you see what I did? My reaction was at equilibrium and I've just disturbed it. How did I disturb it? I disturbed it by what? Adding more molecule of what? Of A. And it's a problem. When I add more molecule of A, what must happen? When I add more molecule of A, it means equilibrium is going to be what? To be disturbed. And which reaction is going to be favored? The reaction that will oppose the disturbance. Remember, I've increased the reactants, right? Reactants, they've just what? Increased. I've increased the reactants by adding more molecule of A. It means if I want to return to equilibrium, I must what? I must get rid of what I've just added. So to return to equilibrium, I must get rid of what I've just added. So look, the solid line is forward reaction and the dotted line is reverse. So since I've added A, which reaction is going to be favored here? For forward or reverse? Remember, according to the Chatelier principle, the reaction is going to favor, the reaction that is going to be favored is the one which opposes the disturbance. The reaction that is going to be favored is the one that opposes the disturbance. So we have a disturbance. Which reaction is going to be favored here? The reaction that is going to be favored is the one that opposes the disturbance. What is the disturbance? We added more reactants. So it means if we want to return to equilibrium, we need to finish these reactants that we have added. It means the reaction that is going to be favored is the formation of products, formation of C and D, so that A decrease. You understand? So it means that the forward reaction is going to increase. The forward reaction is going to increase. Then reverse reaction will need to decrease. Why do we need it to decrease? Because if the reverse reaction can increase, what will it do? It will form more of A, and we don't want A. We want to get rid of A so that the reaction can return to equilibrium. You understand? So it means that, number one, forward reaction is favored. Forward reaction is favored. Understand? We're going to favor the fourth. Why are we favoring the forward direction? It's because we increase A molecules. So since we increase A, we need to decrease A for this reaction to return to equilibrium. So a forward direction is going to be favored. Why are we favoring a forward direction? Because a forward direction uses A to form C and D. So we need to use A so that A gets finished. Then we return to equilibrium. You understand? Forward direction is favored. Then equilibrium shift to right. It will shift to right. It will go this side. You understand? That's how we can explain that one. This one of concentration is not complicated. It's not complicated. Forward direction is is favored. You understand? So that we get rid of what? Of A. That's how we explain this reaction. Then let us talk about this one. Let's say we increase D. We increase what? Increase C molecules. You see what we did? We increase C molecules. C is a what? C is a product, and this product is formed by converting the what? The reactants. So when we increase C molecule, if we want to return to equilibrium, what will we do? We have increased C molecule and the equilibrium is what? Is disturbed. We were at equilibrium, then we increase C molecules. It means equilibrium is disturbed. What must happen? What did we do? We increase C molecule. So if we want to return to equilibrium, we need to remove what we have just increased. We need to get rid of those C molecules that we have increased to return to equilibrium. So which reaction is going to be favored? Will we favor the forward or the reverse reaction? The reverse reaction is going to be favored. Why is reverse reaction favored? It's because the reverse reaction uses C. Reverse reaction get rid of C. The reverse reaction get rid of C. So it means that reverse reaction, it means that reverse reaction is favored. Reverse reaction is favored. Why are we favoring a reverse reaction? Like an increase in C molecule favors the reverse reaction. Increase in C molecule. Let me start. Increase in C molecules favors reverse reaction. That's what is happening. You understand? Favors the reverse reaction, meaning that A plus B will increase. Yeah, I should have written there what's going to increase. A plus B is going to increase. Why is A and B increasing? Then C plus B decrease. Yeah, we need to explain in full, guys, so that we don't lose marks. We need to indicate which one is going to decrease and which one is going to increase and which one is going to be favored. You understand? What did we do? We increased C. We disturbed the equilibrium by increasing the concentration of C. So what must we do to return to equilibrium? We have just increased the concentration of C, meaning that we need to get rid of what? Of the C molecule that we increased. Meaning that if we want to get rid of the C molecules, we need to produce A and B, convert those reactants to what? To products. When we convert those reactants to products, it means C and D, they will start to decrease because we are using them. They will start to what? To decrease. But what about A and B? A and B is going to increase because A and B is formed from these products. You understand? Then the reverse reaction is going to be favored. So that's how it works. That's how concentration affects the rate of reaction. You understand? Okay. The same, let me just write, just for the last time. We increase. Remember I was talking about 1. When we increase 1, it's the same as we increase both. We increase A plus B. We increase A plus B. We increase A and B. Are we together? What's going to happen? When we increase A and B, isn't it our reaction is at equilibrium? And we have increased A and B. What must happen? this A and B must be used so that we go back to what? To equilibrium. So how do we use this one? We promote the forward reaction. Forward reaction because forward reaction is responsible for converting this one to this product. So we must use A and B because we have increased the A and B. We must use them. How do we use them? We promote the forward reaction to form C and D so that A and B can be finished. So it means the forward reaction will be favored. Will be favored. Forward reaction will be favored. Forward reaction will be favored. Then C plus D increase. Why are they increasing? Because we want to use A and B. Remember, A and B are responsible to form C and D, so we want to use them. C and D increase, then A plus B decrease. So that's how we explain. That's how we explain the concentration. That's how concentration affect the equilibrium position. That's how concentration affect the equilibrium position. So now we can talk about the pressure. The lesson is now very long. So it means I will have to create lesson number 2 to teach about KC and factors that affect KC. Let us conclude by talking about pressure. Let us talk about pressure. How pressure causes a shift in equilibrium position. Let us talk about how pressure causes a shift in equilibrium position. How does pressure cause a shift in equilibrium position? How does pressure cause a shift in equilibrium position? So let us talk about it. How pressure causes a shift in the equilibrium position. Notice that how to increase pressure. How to increase pressure. How do you increase pressure? You do what? You increase pressure by decreasing volume. You increase pressure by decreasing volume. So when you increase pressure, you decrease volume. This is a plastic. Can you see? If I want to increase pressure, you see there's no pressure here. But if I want to increase pressure, I'm going to decrease volume like this. You see now? Now there is a what? A pressure. You can see this thing. I can't even press it because the pressure is increased. If I want to increase the pressure even more, I'm going to decrease the volume. You understand? So the pressure started to increase. So if I want to decrease pressure, I will just increase the volume. You understand? So what do we need to know about pressure? So increase of pressure promotes an increase of pressure promotes an increase in molecules or number of moles or concentration. Yes, can even talk about concentration. When we increase pressure, we make more molecules to be available to collide effectively. So when we increase pressure, you see, you find that we have a big volume, we have a larger volume. Then what's going to happen? We don't have enough molecules because the volume is larger. But if we want to increase the concentration, we decrease the what? The volume. When the volume decreases, molecules become concentrated. So when you increase pressure, this is what you are basically doing. You are increasing the number of molecules. You are increasing the number of molecules. You understand? You are increasing the number of molecules. When you do what? You decrease the volume, you increase the number of molecules, you increase the concentration when you increase pressure. So let us talk about how pressure affects equilibrium position. I hope you understood this. How pressure affects equilibrium position. How pressure affects equilibrium position. Okay, let's say we have A plus B, reversible reaction which forms C plus D. Then we have our reaction. Then we have an increase. We have an increase in pressure. We have an increase in pressure. What's going to happen when we increase pressure? Which reaction is going to be favored? It means the reaction that will promote the decrease. Remember, when we increase pressure, what did we do? Our reaction was at equilibrium before we increase pressure. Can you see? Our reaction was at equilibrium before we increase pressure. Then we disturbed the equilibrium. Let's say these are gases. They are gases. Then we disturb the equilibrium by increasing the pressure. So what do we do to do what? To return to equilibrium. If we want to return to equilibrium, remember an increase in pressure increases the what? The concentration. So since the increase in pressure increases the concentration, it means that the reaction that will promote a decrease in concentration, in concentration, in concentration or number of molecules will be favored. Will be favored. You understand? The reaction that will promote the decrease in the concentration or number of molecules will be favored. Because when we increase pressure, what do we do when we increase pressure? When we increase pressure, we are increasing the what? The molecules. When we increase pressure, we are increasing the molecules. So a reaction that will promote the decrease in the concentration or number of moles will be favored. That's how we explain pressure, ladies and gentlemen. Ladies and gentlemen, if you still haven't subscribed to this channel that is giving you powerful stuff like this, I don't know. Subscribe to this channel. Let us promote this channel. We have reached the end of the lesson. Thank you for watching. Go and watch lesson number 2 where we will be talking about KC and we'll be making calculations for KC. So check lesson number 2. I hope this was informative. Thank you very much. Danko.